The process for maneuvering for a contact, as we went over previously, essentially boils down to just plotting a new M3 for a time where you're ready to maneuver for the contact, and then designing a new DRM off of it, determining what the course of that DRM would be, and then applying that to our vector triangle to determine what our course would need to be, or our speed would need to be, to achieve that. You can do this as many times as you want for a single contact. You can change course once and then change course again, and all of the principles are going to hold true. And so that's what we're going to be going over here. There are kind of two ways to go about doing it. One's a lot more common in the Navy. We'll get to that in the next video. But this will be just for having a contact maneuver around us by changing course multiple times. And technically this process is called doglegging, because when you plot out all the new DRMs, you're going to see like a pretty decent change in the angle between them, which I suppose looks like a dog's leg. It also looks like a human or any other animal's leg, but it's referred to as doglegging. So realistically, this would happen in a situation with tons of different contacts that you would need to plot for. I didn't want to draw out all those contacts and create a scenario where you would have to maneuver multiple times, because that sounds like a pain. But in this case, we're just going to do it for a single contact. Now, in reality, for a single contact like this, if you needed to maneuver, you would just change course. And then if you wanted to get back on your original track, you would change course again. Realistically, by eye, you would just wait until it passed away from you, and then you could change course pretty elegantly without having to look at the radar at all. But we're gonna plot it out on the Mo board to see how it would work, and we're gonna do the merchant marine method here, where we're gonna make the vector triangle off of the contact's positions. So we've got a contact here coming in pretty close to us. We don't need to determine what exactly the range of CPA or its bearing is going to be. We know it's here. We also don't need to calculate. I guess we'll calculate time to CPA. I didn't put down times or ranges for these M1, M2. Just trust that they're there. And we're going to assume that they're 6 minutes apart. So step one, we need to find what our SRM is so that we can actually set up the vector triangle. So we'll measure out the distance here. And it comes to 1.2 miles. So again, it's not that hard to figure out what speed it's going if it's at 1.2 miles. There's just about 1.2 right there. A little bit behind the 1.25. But if we connect the dots of 1.2 miles in 6 minutes, we will get 12 knots. So our SRM is 12 knots here. By the way, we're going on course, I think it was 054 at 20 knots. So now that we have our DRM and our vector, we're going to move this over. We're going to try and determine what their true course and speed is, so we can figure out what our rule situation is here. Remember, this is now R, this is now M. So we're going to draw a line in the opposite direction from our vector so we can get R to M, or E to R. And because we're going 20 knots, and this is the distance we would travel in 6 minutes based on this triangle, our vector would be 2 miles long. We could do it, but I trust you know that that's true at this point. So there's the distance we would travel in 6 minutes. We'll plot that right here. There's our E. So then if we connect the dots between the two, we'll get their true course appears to be 0, 3, 0. So we'll draw the contact here. And we'll measure out their speed, which is, looks like 0.95, which would come out to, multiplied by 10, 9.5 knots. So we'll get a true course of approximately 0.30 and a true speed of 9.5 knots. Okay. Really the most important part there was that now that we've got our true course, we can see that it's facing this way, we're facing this way. We appear to be overtaking it. Now, remember, as per the rules, when you're overtaking a contact, you can maneuver in either direction. You could come to port or you can come to starboard. Right now, it's on our starboard bow, slated to cross ahead of us and pass us on our port side. So either course change is acceptable, and I could see an argument for going to either side. Typically passing on the starboard side is just kind of seen as the default, because it's best practice to just always turn to starboard. It's the most predictable behavior, and additionally, it wouldn't require as much of a course change to bring the CPA out to our port side, which would involve a maneuver to starboard. However, technically, you also want to give an early and substantial course change, meaning potentially turning to port would be more substantial and more obvious to them what you're doing. What you choose here is up to you, as long as you can make the argument to your captain that your decision is pretty reasonable, and both of these would be reasonable. You should be fine. Now, I say let's stick with the convention here and turn to starboard. So we're going to pass it on its starboard side. And for this problem, I want to maneuver for it and then plan out a maneuver to come back on track afterwards. So remember, step one is we have to set up an M3 for when we're actually going to change course. For simplicity's sake, because in the past I showed us calculating exactly how far it would be until a precise time of M3, let's just say we're going to make our M3 6 minutes after M2, meaning it would be the exact same distance as it was for M1 to M2, because we assumed that M1 and M2 were taken 6 minutes apart. It's not always going to be the case. Maybe you need more time to prepare than just 6 minutes, but in this case, let's say it took us 6 minutes, or it's going to take us 6 minutes, and we'll be ready to maneuver by then. So that would be the location of M3. Now, we want, let's say a 2-mile CPA. So we want to maneuver so that it will pass 2 miles to port, because that would involve changing course to starboard. By the way, doglegging like this, you would really not be doing with a speed change, because it would be very unreasonable for a person to be constantly changing speed like that, to the point that they would need to set up a mo board for it. In reality, you're going to be changing course. So we want to set up a new DRM that would pass to our port side at 2 miles from M3. And we'll get it going right through there. All right. And we want this for this DRM to be true, we need to figure out what our course would be for it. So we'll carry over the DRM to our M value, because remember, E and M are going to stay the same, because the only thing we can change is E to R, and as in doing so would affect the RM vector. So this is our new RM line, and to figure out our where ER is going to land on it, we need to determine our speed. In this case, we're keeping speed the same. So ER is going to be the same length as ER prime. So we just move it down, swing an arc. If we had a compass, we would actually show you swinging the arc here. We find where it intersects our new RM vector, and it lands right there. So that's R prime. It's not perfect. That's better. Okay. That's our new ER vector. We know the speed is the same, but to find the course that we'd be following, looks like we get 0, 6, 0. So we'll write up here, new course number 1 is 0, 6, 0. So we're currently on 0, 5, 4. If we come right to 0, 6, 0, we'll have them pass us with us to their starboard side as per the rules, with a CPA of 2 nautical miles. So this would be a safe passage, not necessarily a substantial enough course change to be really satisfactory with the rules, because they won't necessarily be able to tell what we're doing until substantial time later. But it technically is fine. However, what this means is if we were on course 054, we want to stay on course 054. We can't just come to 060 and go that way forever. So at some point, we have to come back on track. And to do so, we can't just come to 054. We're going to have to come, we're going to have to turn even more than that, because we're going to have to overcorrect. Realistically, when you're choosing a new course to follow back to your track line, you can kind of choose whatever you want. You could turn a full 90 degrees and go straight back, or you could take it nice and gradual. It's really up to the individual how extreme they want that course change to be. Though in this case, we're going to have to make sure it stays in compliance with avoiding this contact. Firstly, what that means is we're not going to let it come within 2 nautical miles. So before we can plan out what our maneuver is going to be, but we can't maneuver until it's past us. We don't want to change course back towards it until it's at least past its new CPA. Which, by the way, let's mark its new CPA. Appears to be right there. So at the very least, we shouldn't be turning towards it until it's here. Now, sometimes you can accommodate that. I mean, you could just follow its stern back towards your original course, but depending on how large you set your CPA to be with it, that may or may not be a smart idea. I mean, if you set your CPA to be half a mile, then that's a pretty risky move, but at 2 miles, you could probably do it. However, for here, we're going to say we wait until it passes our CPA, then we maneuver again. It's the same exact process. We're going to find an M, now an M4, not an M3, a point that we're going to choose to maneuver for, or choose when we're going to maneuver for it. We should at that point find how long until that M3. And then from there, we're going to set a new DRM that has it pass back the other way so that we can now come back on track. The most expedient way to do this is to actually start with the DRM, because what you want is, well, I guess actually that's not necessarily true. You could just set your M4 to any point past here. Now, it can't be at the CPA, because if it's at the CPA, you're not going to be able to turn inward without having it pass into within 2 miles. So sometime a little while after it, maybe here. You can either pick an arbitrary point on the chart or on the plotting sheet and label that M4, or you could pick a period of time that you want to wait. Before we do anything else, we should find how long between these 2 points. Firstly, we need to know what our RM vector is. We never actually calculated that, though it wasn't necessarily required. So that's the length of the new RM vector, so the R prime M vector, which is 1.2 miles. Remember, it's a 6-minute triangle, so that means this new vector happens to also be 12 knots. Or the original was like 11 knots. So yeah, this new vector is 12 knots, meaning it's going 12 knots along this line of relative motion. So we're going to measure out how far this is to see how long from M3 to M4 it's going to be. And we get a distance of 7.7 nautical miles. So that's not something I can do in my head. So how long is it going to take a contact moving at 12 knots to go 7.7 nautical miles? If we connect the two, we get 38 minutes. Okay. So remember, we never set exact times, but let's do that right now and just say if this was 1200, then M2 was at 1206, meaning M3 we said was 6 minutes later. So this is 1212. This is now 38 minutes later for M4. So what, 1250? So we're going to plan to make our maneuver back on track at 1250. Now, if we want to get back on track, we're going to have to come to the left. And a maneuver to the left would mean that their DRM would now go off this way towards our right side. If you can visualize that, you could see it having passed astern of us now would now shift off onto our starboard side. That would be what this is representing. So any angle like that would have that result, including if we had the DRM like that, that would be turning way up this way. But we want to stay keeping it 2 miles away. So what we're going to do is find the sharpest angle we could turn to, which would be the one that is once again tangent to our preset CPA limits, and that's it right there. So the story we're telling here is a contact that was moving on this line of relative motion. We maneuvered to avoid it, which meant it started passing this way. Remember, it's still facing this direction the whole time. It went from sliding down to now sliding across here, and now we're going to maneuver to the left once it's past us, and it's going to start moving that way. So now if we want to find what the new course is going to be for that, we take this new DRM, slide it all the way over, and the triangle slid a little bit, so we're going to have to do that again. Remember, this is the RM line, so we're going to have to set this off of M once again, because M has never changed. And move it that way, in the opposite direction, because then we can find R2M. So we're still not changing our speed. Remember, if you wanted to, you could do all this by manipulating speed too. It's just very unlikely that that would be something you would practically do. We measure out 20 knots like we've been making good this whole time, and we bring it to the new RM. And so that will be our double prime M for the new course we're going to go in. Our new course to steer will be E to R double prime, which looks like it's nearly a parallel course with the contact itself. There we go. And we get an angle, a course of 029.5. So new course number 2 is 029.5. Remember what that is after they've passed astern of us, we can now start coming back towards our track line. So we could change course to 029.5 and then head that way. And then once we actually meet our track, meaning, on Ectus we see that our cross track error is 0 because we're on the track line, we could come back to our original course of 054. At that point, we wouldn't need to do a mow board because they're already astern of us and they're moving further away. So a new course change back to 054 wouldn't involve any concern with them. They're way behind us. So this is how you do multiple maneuvers for a single contact. And remember, if we had a mow board with multiple contacts all around us, you would have to calculate these course changes and how they would affect all of your contacts, or at least the ones you know that are going to present a risk. If something's way out here and departing at the beginning, and it's way out here and departing at your second course change, your third course change, or at your first course change, Your second course change is probably still not going to cause a threat there unless you were to turn straight at it. Yeah, and so that's doglegging. If you want to imagine a dog, I guess there's its leg.